Here's a recap of the central limit theorem for proportions. So we talked in class that for sample proportions to be approximately normal, we require that n times p be greater than or equal to 10, and n times 1 minus p be greater than or equal to 10. So basically our successes and our failures have to be much greater than 10. Or equal to them. So if this is true, then we can approximately say that the sample proportion will be normal with a mean of p and a standard error of square root of p 1 minus p. So remember, this is basically the standard deviation, or sigma, but we call it a fancy word called standard error. So here's an example. So Shaquille O'Neal has a lifetime free throw percentage rate of 52.7%. So suppose that his free throw attempts are independent from one another. So can the central limit theorem for proportions be used here when he shoots 40 free throws, and what about 15 free throws? So in other words, we want to figure out, is 40 or 15 large enough? So first, let's check 40. So when n is equal to 40, well, Shaquille O'Neal's free throw percentage rate isn't going to change. So P here is going to be 0.527. So first, let's check that to see if that's large enough, and then we'll check if 15 is large enough. So in order for me to do that, well, I need to know that n times p has to be greater than or equal to 10, and n times 1 minus p also has to be greater than or equal to 10. So n is 40, so 40 times 0.527. So let's plug that into our calculator. So 40 times 0.527, this is 21.08, which it is greater than 10. And then if we do 40 times 1 minus 0.527, well, let's put this in our calculator. 40 times 1 minus 0.527, we end up getting 18.92. This is greater than or equal to 10. So n equals 40 is large enough, so we can use it. You can use central limit theorem. So n equals 40 is large. So the answer is a yes. We can use central limit theorem here. Now, what about n equals 15? So we got to do the same thing. N times p has to be greater than or equal to 10, and n 1 minus p has to also be greater than or equal to 10. So 15 times 0.527. Let's figure this out. So 15 times 0.527, this gives me 7.905, and clearly this is not greater than 10. And at that point, you don't even need to check this thing because we've already gotten a contradiction. So the answer here is no, cannot use central limit theorem for proportions. It's too small, it's not going to be approximately normal. Okay, so now part B, what it's asking us to do is write out the sampling distribution when Shaq shoots 40 free throws. Okay, so remember, the sampling distribution is just going to be p hat is normally distributed. We need to figure out what p is, and we need to figure out what square root of p 1 minus p over n is. Since we've already said that 40 is large enough, all we got to do is just plug in p and n into this distribution. So we have p hat is normally distributed. P in this case is what we believe Shaq's percentage rate to be, which is 0.527. And here we're going to have square root of 0.527, 1 minus 0.527, divided by n, and n in this case is going to be these 40 free throws. So p hat normally distributed 0.527, and this thing is going to be square root. So let me put this in the calculator. 0.527, 1 minus 0.527 divided by 40. Okay, and what I end up getting rounded to 3 decimal places is 0.078. 9. Okay, so this should be a 9. Okay, so this is my sampling distribution. This is what I'm asking for whenever I ask for something like that. Okay, and usually on an exam, I will fill in the blank here, so then you would just have to plug them in. Okay, so now let's do part C. So part C is asking us, what is the probability that he makes more than 50% of his free throws? So round to 3 decimal places. So let's draw a picture. I think the way to do this problem and any problem that deals with normal, always draw a picture. Okay, so we know that our mean is going to be 0.527. We want to make sure to find the probability that he makes more than 50% of his free throws. So more than 50%, well, 0.5 is around here. It's a little bit less than that. 0.5 is there, that's 50%. And then since we're talking about more than that, it's going to be all of this area. Okay, so now because we know that this is approximately normal, we can use normal CDF. So norm CDF, here our lower bound is going to be 0.5 because that's where the area starts. My upper bound is going to go off to infinity. Okay, my mean, mu, is going to be 0.527, and my sigma, or my standard error, is going to be 0.079. Okay, so let's see what this is, and let's round it to 3 decimal places. So use your calculator. So second data, distributions, go down to binomial, oh no, not binomial, sorry, normal CDF. Our mean is going to be 0.527. Our sigma is going to be 0.079. Our lower bound is going to be 0.5, and my upper bound is going to be infinity. So you just leave it like that for TI-36. If you have the graphing calculator, literally just write everything, all of these things down. And my answer is going to be 0.634, since we want 3 decimal places. So there is a oops, what is going on here? Oops. So there's about a 63.4% chance that more than 50% of his free throws will land. Okay. All right. So now let's go ahead and go to the next problem. What is the probability that he makes less than 40% of his free throws? So let me draw it one more time. Okay. Our mean hasn't changed, it's still 0.527, and then make less than 40% of his free throws. So here's 0.4 or 40%, and then less is going to be everything lower. Okay, so we're still going to use normal CDF. My lower bound, in this case, notice that it doesn't start at 0.4 anymore. It starts a little bit smaller than this, and this goes off to negative infinity. So my lower bound is going to be negative infinity. My upper bound in this case is going to be 0.4. My mean is going to be 0.527. And my sigma is going to be still the same, 0.079, since we're still dealing with the 40 free throws. Okay. All right, so what is this going to give me? So I'm going to put distributions, normal CDF. My mean stays the same, so does my sigma. My lower bound is going to be negative infinity, and my upper bound is going to be 0.4. Okay, so the chances that he makes less than 40% of them is going to be 0.054. Okay. All right, and that is my answer. So everything is just basically our normal. Using normal CDF, it's just that we needed to figure out what this sampling distribution is. And once we find our mean and our sigma, then we can go ahead and do these problems.